The universe is vast, it is dark, and it is mostly silent. For all of human history we have stared up at the night sky and felt a sense of wonder, a feeling of smallness in the face of cosmic grandeur, but we were looking at the universe with our eyes half closed. The cosmos is filled with things we cannot see. It is a place of unimaginable violence and breathtaking beauty, often at the same time. Black holes, with gravity so strong that not even light can escape, lurk in the centers of galaxies, including our own Milky Way. The darkness between the stars is not empty. It's a seething cauldron of possibility where the laws of physics are pushed to their absolute limits. To see the invisible, you need a very special kind of eye. Humanity's newest and greatest eye on the universe is the James Webb Space Telescope. It is an engineering marvel, a testament to human ingenuity and our unyielding desire to know. Unlike Hubble, which sees invisible light, Webb is designed to see in the infrared. Like a firefighter using thermal vision to see through smoke, Webb uses its infrared vision to see through vast clouds of cosmic dust and gas that obscure our view of the universe's earliest objects. Webb has a massive 5-layer sunshield the size of a tennis court. This shield acts like a giant parasol, blocking heat from the sun, earth, and moon. On the sun-facing side, the temperature is hot enough to boil water, but on the shaded side, the temperature plummets to 370 degrees below 0 Fahrenheit. The team of astronomers had a clear mission. They were going to point Webb at one of the emptiest, most boring patches of sky they could find. The chosen target was the Eridanus Void, a vast, dark expanse where the density of galaxies is unusually low, one of the great deserts of the cosmos. The observation was scheduled to last over 200 hours. As the first packets of data began to arrive, the mood was electric. As more data was integrated, a picture began to emerge from the noise. The faint red smudges of the first galaxies started to appear right where the models predicted. But as they continued to analyze the deep field, they noticed something else. Something subtle at first. An anomaly. A pattern in the data that shouldn't be there. It was a ghost in the machine. A whisper from the void that would soon grow into a roar. The anomaly was first noticed in a map of gravitational lensing. There was a wave in the data. A large-scale, coherent distortion that stretched across the entire field of view. It was as if something enormous and completely invisible was subtly bending the fabric of space-time itself. The initial reaction was that it had to be an error. The team spent weeks trying to eliminate the signal. They recalibrated the instruments, reran the analysis, checked for interference. But the signal refused to go away. It was real. The implications were staggering. The force causing this distortion seemed to be everywhere in that patch of sky, an omnipresent influence, and it was powerful. The team decided to call it the cosmic undertow. The name captured the feeling perfectly, a massive, powerful current moving beneath the surface, shaping everything. The first candidate was dark matter. We already know that 85% of the matter in the universe is dark, meaning it doesn't interact with light. However, the undertow was different. It was too uniform, too widespread. It wasn't clumpy at all. Another possibility was primordial black holes, forged in the fiery chaos of the Big Bang itself. If spread throughout the early universe, their combined gravity could create the smooth distortion Webb observed. Could this be a new manifestation of dark energy, or an interaction between dark energy and dark matter that only occurs under extreme conditions of the early universe? The most thrilling possibility is that the cosmic undertow is something entirely new. A fifth force of nature or a new type of energy field that has remained completely hidden from us. Webb didn't just find new stars or galaxies, it found a ghostly presence that has been shaping the universe since its infancy. A discovery of this magnitude is not just a new chapter in astronomy, it's a whole new volume. The standard model of cosmology is now in question. Every major telescope will be tasked with hunting for more evidence of the undertow, looking for its gravitational signature in other parts of the sky. This single discovery could inspire a generation of young scientists, sparking a new golden age of theoretical physics as we race to understand this cosmic ghost. It will require new technologies and entirely new space missions designed specifically to map this invisible force. For centuries, we navigated the cosmos using a map drawn in light, but the cosmic undertow reveals we were reading only the surface. Our old maps are obsolete. We have to start drawing a new one. This new map will include the gravitational contours of dark matter, the repulsive pressure of dark energy, and now, the directional pull of the cosmic undertow. The discovery reminds us of our own smallness in the grand cosmic scheme. We may be small, but we are a part of this magnificent cosmos, and we are its consciousness. As we stand on the shore of this newly discovered cosmic ocean, with its invisible and powerful currents, we must ask ourselves, what else is out there, waiting in the dark? The universe just became a much bigger, more mysterious, and infinitely more interesting place. The search for knowledge is a journey without a final destination.